Hello everyone. My name is Sanya Sigir and I'm a student of first SEM CSE in Sri Venkateswara College of Engineering. My presentation is on construction and advantages of future mobility vehicles in automobile industry. This is an overview of the topics that we will be covering today. I will be talking about IC engine, electric vehicles and hybrid vehicles in detail. So, before we get started, I would like to give an example. Let me play a short clip for you guys.
Remote driving system activated.
That was thrilling, wasn't it? This is an example of technological advancement where we can see Shuri driving a car remotely on the basis of advanced technology. Though it's just fictional, it makes us wonder what real life cars can do in the future. This also aligns with the futuristic aspect of controlling vehicles remotely or autonomously. So, let's understand the concept of future mobility vehicles. These are the cars and other ways which will get around in the future. They are going to be really different from what we have now. They might be powered by electricity instead of gas, so they won't make pollution. Some might even drive themselves, like having a smart robot as the driver. Imagine buses that can change their routes based on what people need to go. They might look cooler, work together better, and help make cities less crowded and air cleaner. These future vehicles are all about being more advanced, kinder to the environment, and making it easier to move around. So, moving forward, we have the IC engine, which is also known as internal combustion engine. These are the machines that generate mechanical power by burning fuel inside a combustion chamber. There are primarily two types, two-stroke engine and four-stroke engine. Two-stroke engine is also known as gasoline engine and four-stroke engine is also known as powered diesel engine. Now, let's understand the working of IC engine. The first step is air intake. The engine pulls in air through an intake valve as the piston moves down in the cylinder. Next, we have fuel injection. Fuel injection. This in two-stroke engine, a fuel injector sprays a fine mist of fuel into the air, creating a highly combustible mixture. In four-stroke engine, fuel is injected at high pressure into the hot compressed air. In both cases, the mixture is ignited to create combustion. Next, we have the combustion stage. The ignited fuel-air mixture rapidly burns, producing high-pressure gases. Then we have the power stroke. The pressure from the combustion forces the piston downward the significant force. At last, we have the exhaust. The exhaust valves opens allowing the burnt gases to exit the cylinder and therefore the cycle repeats. This repeated process drives the piston which are connected to a crankshaft and ultimately generates the mechanical power. Next, the two types of future mobility vehicles that I will be discussing today are the electric vehicles and hybrid vehicles. So, let's get started with electric vehicles. Electric vehicles run on electricity instead of petrol or diesel. They use a battery to power an electric motor. Basically, they are like big versions of the remote control cars you might play with. They are a big part of future mobility because they are better for the environment. They are also paving the way for more high-tech transportation, like self-driving cars and vehicles that can communicate with each other to avoid accidents. For example, Tesla. Tesla makes cars run solely on electricity using advanced batteries to store energy. Now, let's talk about the components of electric vehicle. This diagram will help you understand better the components, which include motor, reducer, battery, onboard charger, and electric power control unit. So here we have the motor. The motor converts electrical energy into kinetic energy that moves the wheels. The advantage of using the motor instead of engine is numerous. Firstly, the noise and the vibration we typically associate with cars are minimalized. Next up, we have the reducer. The reducer is a kind of transmission that serves effectively and conveys the motor's power to the wheel. The reducer must always reduce the RPM to an appropriate level. Then we have battery. The battery stores electrical energy and is the equivalent of fuel tank in an internal combustion engine. The maximum driving distance of an EV is often determined by battery capacity. The higher the capacity, the higher the driving distance. Next up, we have onboard charger. The onboard charger or OBC is used to convert alternating current first slow chargers or portable chargers used to home outlets into direct current. The OBC is used for charging and the inverter is for acceleration or deceleration. At last, we have Electric Power Control Unit or EPCU. The Electric Power Control Unit consists of inverter, the low voltage DC current converter, or the vehicle control unit. So now let's start with inverter. The inverter converts the battery's DC into AC, which then is used to control the motor speed. Next, we have low voltage DC converter. The LDC converter, the higher the voltage electricity from the EV's high voltage battery into low voltage and supplies it to the voltage various electronic systems. Next is the vehicle control unit. It controls all the vehicle's power control mechanisms, including the motor control and braking control, and the power supply for electronic systems. So now let's talk about some of the advantages of electric vehicles. First, we have reduces air pollution. Since electric vehicles do not use fuel for combustion, there are no emissions or gas hazardous exhaust. Vehicles that run on fossil fuels contribute significantly. Next, we have better for our energy security. Rapid adoption of electric vehicles would help reduce India's crude oil import. Then we have the less noise and smoother motion. Driving an electric car is significantly smoother because they lack fast moving elements that are quieter and produce less noise. Then we have cost effective. Electricity is far less expensive than fuels such as gasoline and diesel, which are subject to regular price increases. At last, we have the low maintenance. Electric cars have fewer motion components, wear and tear is reduced when compared to traditional auto parts. Repairs are also simpler and less expensive than combustion engines. Moving forward, we have the second type of future mobility vehicles, that is hybrid vehicles. Hybrid vehicles use two types of power sources to move: a traditional gasoline engine, like regular cars have, and an electric motor. These cars can switch between using gasoline and electricity or using both at the same time. Hybrids help save the gas and reduce pollution because they use less fuel and produce fewer emissions than traditional cars. Let's discuss about some of the components of hybrid vehicles. First, we have gasoline engine. The hybrid vehicle still has a gasoline engine. This remains to be main power source of the vehicle. Next, we have the electric motor. This is the feature that makes the hybrid vehicle partially special. The electric power has the ability to accelerate the vehicle by taking power from the battery. Next, we have the fuel tank. Due to the advanced technology in hybrid cars, the fuel won't be needed as much. There will be better fuel efficiency and produce fewer emissions. Then we have the transmission. Most hybrid vehicles will still use a conventional transmission that you would find in a regular gasoline car. However, there are few transmissions built specifically for certain hybrid vehicles. And then at last we have the battery. These batteries are what power the electric motor of a hybrid car. Batteries can take back the power from the electric motor too. Now, let's talk about some of the advantages of hybrid vehicles. Hybrid vehicles are environment friendly. One of the biggest advantages of hybrid car over gasoline powered car is that it runs cleaner and it has better gas mileage, which makes it environment friendly. Next, we have financial benefits. Hybrid cars are supported by various number of credit and incentives which makes it affordable. Next, we have less dependence of fossil fuel. A hybrid car is much cleaner and requires less fuel to run, which means fewer emission and less dependence on fossil fuel. This in turn also helps to reduce the price of gasoline in domestic market. Next, we have regenerative braking system. An internal mechanism kicks in that captures the energy release and uses it to charge the battery, which in turn eliminates the amount of time and need for stopping the rechargeable battery periodically. At last, we have the built from light material. Hybrid vehicles are made up of lighter materials, which means less energy is required. The energy is smaller and lighter, which also saves much energy. To conclude it, the future of mobility vehicles in the automotive industry is undergoing a significant transformation. Traditional internal combustion engines are making way for electric and hybrid vehicles. Electric vehicles powered by advanced batteries promise zero emission and a cleaner environment. Hybrid, blending gas engines with electric power, offer a middle ground for efficiency. This shift signals a move toward cleaner, smarter, and more sustainable transportation options. Thank you for watching.